So the cryosphere is basically a subset of the hydrosphere. It's the frozen water on our planet, and that would include the frozen sea ice, the glaciers, and the frozen ground, like the permafrost. The northern hemisphere contains much more land mass than the southern hemisphere. And on the northern hemisphere, we find that at least during the winter months or the winter season, that at least a quarter of that land is covered with snow and ice and frozen ground. And it will thaw to some degree during the summer months. But also, speaking of thawing and melting ice, that does contribute a great deal to the moisture in the ground or the groundwater and the water that enters into stream systems and rivers, which is not only important to humans, but also plays a big role in the way that ecosystems and the biosphere functions, and the way in which the water moves on our planet. Now, a big portion of this chapter is dedicated to the discussion of glaciers. So a glacier is really a thick body of snow and ice that's compacted and that moves. And so that essentially defines what a glacier is. Then there's different types of glaciers. There's the cirque, which is sort of the smallest form of a glacier that would be found like on the side of a mountain. This is sort of a crevasse in the mountain. And then there are valley glaciers that will inhabit and move through a valley. Ice caps. Those are glaciers that will move in all directions, like on the top of a mountain or elevated portion of land. Forge, which is essentially a valley, but a very steep valley formed as a result of glaciation, but that enters into like an inlet. And if you think of Norway or New Zealand, a lot of those, you'll find a lot of the forge there. A Piedmont is a valley glacier that extends out of that valley. So glaciers can be found in mid-latitudes, but also the southern and northern latitudes associated with high mountain ranges in the mid-latitudes, but also can form at the high and low latitudes, like the northern hemisphere, the northern pole and the southern pole. The greatest glaciers, or the highest percent of glaciation, occurs with Greenland and Antarctica, and really that constitutes about 95% of the glaciers found on this planet. In fact, it's quite extensive in those regions as far as the ice that covers them. Of course, the glaciers themselves are so dense and so compacted that the ice itself is actually considered or classified by geologists as a rock. So that's pretty dense stuff. Glaciers will advance and retreat, and there's sort of this dynamic balance by what accumulates or is added to the glaciers through snowfall, and also what is lost, or the ablation to those glaciers. The front of a glacier is termed the terminus. When the terminus meets a large body of water, such as a sea or a bay or an ocean, that terminus will slough off, and that is called calving. So calving events will form oftentimes icebergs that will float out to sea. And there is an internal flow to glaciers. The glaciers themselves, the flow is the greatest towards the surface of the glacier and also the central portion of that glacier, and it's slowest around the margins and the bottom of that glacier, although the bottom will flow as the friction of that glacier moves against rock. A liquid water will actually form, so it can kind of glide along the basin of that glacier. There are if we think through geologic time here, there are periods of, or interglacial periods and glaciated periods. And so we're in the midst of an interglacial period. Of course, we're pretty aware now, at least the scientific community is pretty aware now, that not only are we in the midst of an interglacial period where the ice has retreated, the coastlines have expanded due to the freeing of the ice, but we're experiencing a warming period where there's, and I say expanding, coastlines actually retreating, but we're in the midst of an interglacial period, and we've amplified the effect, the warming effect, due to the activities of humans, whether it's adding the carbon dioxide and methane to the atmosphere, which adds to the warming of the atmosphere. But we have gone through periods, interglacial periods, or glaciated periods. 10,000, 20,000 years ago, we were in the middle of a glaciated period. So it's sort of oscillated, or been a cyclical process throughout time. So during glaciation periods, glaciers expand and new ones form. Interglacial periods, ice sheets retreat and sea levels tend to rise. Once again, we are definitely in the midst of an interglacial period. Glaciers definitely sculpt and shape the landscape around us. They do form cirques on mountainsides. Artiques, which are very sharp ridges along mountain chains. U-shaped valleys, the forges. Drumlins, which are sort of little rolling hills. Tills are odd sort of anomalies, large rocks, boulders that will be placed along the path of a glacier. Outwashes, moraines, eskers, kettles, like forming kettle lakes. So glaciers definitely shape and characterize the landscape in a more slow process maybe than a river might shape the land. Permafrost now, stepping to another arena here. Permafrost is frozen ground. Permafrost is considered paraglacial. In other words, it's beyond the limits of the glaciers, and it's mainly found in the circumpolar regions, associated with the northern and southern hemispheres, especially the northern hemisphere. And speaking of ages of ice, by the way, most glaciers associated with mountain ranges, especially like the Alps, the Andes, the northern Rockies, those glaciers can date back hundreds of years, thousands of years even, but our oldest, deepest ice would be associated with like Antarctica or Greenland, and they can date back 100,000 years, hundreds of thousands of years. Some of those well over 600,000 years in age. And those ice cores that are taken from there can be used to reconstruct or analyze what the atmosphere would have been like that far back, which is very interesting. Sea ice is a very dynamic thing. It's very dynamic, it's very thin, it's very sensitive to temperature change. It has been demonstrated that the sea ice has been shrinking in both the southern and northern hemispheres. But the sea ice itself sort of exists as a barrier between the ocean below and the ice above, the atmosphere above. And of course, the ice below, as ice freezes, it's just the fresh water that will freeze, or the salt doesn't freeze, and so it becomes super saline or super high in solutes below, and it's cold and it's dense. But it does serve as a barrier between the ocean itself and the atmosphere. And there is sort of a positive feedback effect that maybe should be mentioned associated with sea ice. When sea ice is there, of course it's white, there's an albedo effect, and it will promote cooling. But if sea ice diminishes because of a warmer atmosphere or a warmer ocean, then if that sea ice diminishes, open ocean tends to heat up faster and can actually melt more sea ice. So in either direction, a positive feedback can take place. So that dynamic equilibrium is actually quite fragile, and it is something to consider when you're thinking about climate change and atmospheric warming.